Assalamu alaikum. Today we are going to convert the linear structure fructose into a ring form, and especially the D fructose into its two form, beta D fructose and alpha D fructose. The linear structure that I will draw, we call it Fischer projection, and the cyclic structure that will be formed, we call it a ring structure. So first we will draw the linear structure starting from carbon number 1. Carbon number 1 is 3, 4, 5 and 6. It is also CS2OH. Okay. Now the first carbon number 1, this is carbon number 2, this is carbon number 3, and we number them. It's carbon number 4, and it's carbon number 5, and it's carbon number 6. The carbon number 2, now we will write bonding of these carbons. So carbon number 2 is double bonded with oxygen, and this carbon is positive, and I will tell you why I mentioned that. Let's draw the bonding of other carbons as well. So carbon number 3 have hydrogen on the right side and hydroxyl group on the left side, while the carbon number 4 have hydroxyl group on the right side and hydrogen group on the left side. And here in the C5, carbon number 5, the hydroxyl group is present on the right side. And if it's not present on the right side, then it will not be D fructose, because D fructose means dextra and dextra mean on the right side. It means that the carbon number 5 must have a hydroxyl group on the right side for fructose to be a D fructose. So whenever hydroxyl group will on the right side, we will call this structure, this linear structure is of D fructose. This carbon number 2 is positive, and as a result of this, the hydroxyl group of carbon 5, the oxygen basically in the hydroxyl group will attack on this positive carbon in the cyclic form to form a closed ring. So ring will close as a result of bonding between the carbon number 5 and carbon number 2, and especially because carbon number 2 is positive. Now the first step of converting this linear structure into a cyclic form is to rotate this linear structure on the right side at 90-degree angle. So when we rotate this structure on the 90 degree, the first carbon number 1 will be on the right side, and carbon number 6 will be on the left side of this flat chain that we draw. Let's draw the carbons first. Carbon number 6. Okay. First will be carbon 1, 2, 3, 4, 5, and 6. Carbon number 1 have S2OH attached to it, that we will draw over here. Now, in order to write the bonds of these, we have to first understand the whatever is on the right side of the linear structure, because we rotate it on the right side. So whatever the bonding of these carbons, the hydrogen or hydroxyl group on the right side, when we rotate them on 90 degree, they will on the down side. So they will on the down side of this flat chain, and whatever that is present on the left side of this linear structure will be on the upward side. So let's say carbon number 2 has carbonyl group, have a double bond of oxygen on the right side, it will be now written on the down side. And carbon 3 hydrogen is on right side, so it will be written on the down side of this chain, and hydroxyl group will be up. Same with all of these. Carbon 4 hydroxyl group will be down, and hydrogen group will be up, like this. Carbon 5 hydroxyl group is on the right side, that's why it will be down, and hydrogen group will be above. And carbon number 6 have C(H2OH) attached to it. Okay, so this is the flat chain that result as a result of rotation at 90 degree angle. This was the first step of converting it into a cyclic form. Now, so when it is this flat chain will form a ring structure. Before it, I want to tell you the carbon number 1 and 2 and carbon number 5 and 6, they will be rotated above, but the carbon 3 and carbon 4 will remain fixed at their position. They will not change, they will not undergo any rotation. They will remain fixed at their position, and the rest of the carbon 1 and 2 on the right side and carbon 5 and 6 on the left side will form a ring around it. But this ring will be a kind of open ring, because still the bonding is not formed between the carbons 2 and 5, which will be formed in the end. Okay, so now what we will do, we'll draw it, a ring structure that will be formed. Well, there we have a ring structure. Let me, write this on the side and start over. Okay. So now I will write the name of carbons. I say that carbon 3 and carbon 4 will remain fixed in this chain. Their hydroxyl group, their hydrogen group will not change position. Okay, so carbon 5 will on the left side along with carbon 6, and carbon 2 on the ring will be on the right side, and attached to it will be carbon number 1 attached to the carbon number 2. Okay, so this kind of ring will be formed around carbon 3 and carbon 4. Now we'll draw the bonds above them. Carbon 3 hydroxyl group on the above, like in the flat chain, because they are fixed. They don't go into kind of rotation. Carbon 4, they have hydrogen above. And hydroxyl group down. The carbon 5, it will also have a hydroxyl group down and hydrogen group above, as in the flat chain. It go in the rotation a little bit of tilted, but not as much. CS2OH attached to carbon number 6 position. So here I have shown you all the bonds. Remaining carbon number 2 have a carbonyl group facing down. Okay, but still I told you already that a bond will form and attack will be done by the hydroxyl group of carbon 5 on the carbon of carbon number 2. So in order to attack to be done by this hydroxyl group, there is not enough space. The hydroxyl group can't do attack on carbon 2. So in order to get a position close to this carbon number 2, this hydroxyl group will get the position of carbon 6, and this carbon 6 will get the position of hydrogen over there on the carbon 5, and this hydrogen will get the position of hydroxyl group. So there is basically an anti-clockwise rotation will be happening, because of which hydroxyl group will be close to the carbon number 2 and have a more chance of attacking on it. So when we anti-clockwise rotate it, the structure will look like this. Let me draw it. So now on carbon 5, on the place of carbon 6 we have hydroxyl group, and on the place of hydrogen we have a carbon number 6, and on place of hydroxyl group we have hydrogen atom there. So this result as a result of anti-clockwise movement rotation that occurs, so the hydroxyl group can attack on this carbonyl carbon of carbon number 2. This is carbon number 1, CS2OH. Okay, now I'll draw the bonds. Now the hydroxyl group can attack on this carbon number 2. If this hydroxyl group will be attacking on the carbon 2 on the above side, then the alpha fructose will be formed because the hydroxyl group position will be down on the carbon 2. But if this hydroxyl group of carbon 5 attack on carbon 2 on the downside, then beta fructose will be formed. Actually, in the hydroxyl group, the oxygen will attack on the carbon, and as a result, the bond between the carbon and oxygen will be broken. And as a result of this oxygen of carbon 2 become negative. When it becomes negative, the hydroxyl group of carbon 5, the hydrogen of it will be form bond with the oxygen atom and form a hydroxyl group on the downward side. So let me draw a alpha fructose formed by the attacking of hydroxyl group on carbon number 2 on the upward side. So here I am drawing this. So oxygen bond will be formed between carbon 2 and carbon 5 because of attacking of hydroxyl group on carbon number 2 on the upward side. But the hydrogen of this hydroxyl group of carbon 5 will be forming the bond with the oxygen of carbon 2, the one you see with the double bond, because this double bond will be broken and the oxygen will become highly negative. So a bond will form between the hydrogen and oxygen as well, forming a OH group, hydroxyl group, that will form on the lower side in the alpha fructose, OH. This is carbon number 1. So this type of structure of fructose, in which hydroxyl group of carbon 2 is facing downward position, it means that it is an alpha fructose. Now we will see what will happen if the hydroxyl group will attack on this carbon number 2 on the downward side. So new form of fructose will be formed. Let me erase this. And this new form will be called as beta fructose because it will have an hydroxyl group facing upward on the carbon 2. So in this case, the arrangement of carbonyl group will also be changed. It will also facing the C double bond O of carbon 2 will also be facing upward direction. So when the OH group will attack on the downward position, a bond will be formed between the oxygen and carbon number 2 and carbon 5, and a bond between oxygen and carbon will be broken and oxygen become negative. So the hydrogen of C5 will form bond with it, forming a OH group on the upward side. So now I'm drawing the beta fructose, how it will be formed. Like I said, oxygen bond will form between carbon number 2 and carbon 5. Here I'm representing carbon by only numbers. So here on the carbon number 2, the OH will be formed on the above. So the carbon 1 will be pushed a little on down. C H2OH. So this kind of structure of fructose, where a hydroxyl group of carbon 2 is facing upward on the upper side, we call it beta fructose. Carbon number 2 hydroxyl group is upward, facing up. Then what kind of fructose will form? Beta fructose. So closed ring is formed because of the bonding between carbon 2 and carbon 5 because of attack of hydroxyl group of carbon 5 on positive carbon of carbon 2. So in the first step, we convert the linear structure, rotate the linear structure 90 degree, and then we form a ring, but this ring was an open ring because no bonding is occurring between carbon 2 and carbon 5. And then we have to rotate the hydroxyl group and carbon 6 so that the hydroxyl group become on the upper side and it can attack carbon 2. So in the third step, what happened? Actually, the attack of hydroxyl group on carbon 2 happens. So when you attack from the upper side, alpha fructose will form. When the hydroxyl group of carbon 5 will attack downward side on carbon 2, then beta fructose will be formed.